right? So you have compression at the top, and then you have tension at the bottom. And then if you add these two equations, right? If you add these two equations, if you now add both of them, right? Now you add both of them. So now we are going to plot stress X. Okay, so now we're going to plot. So I'm going to show you what's going to happen. Okay. So now if we're going to plot stress X, right? So this is equal to stress X is equal to P over A, right? Plus or minus MZ, okay, P over A, or PX over A, plus by MZ over IZZ multiplied by Y, right? So what will happen now is this. Okay, I'm going to get rid of all this. It's okay. I just got rid of the slope, which is important to me. But it's okay. Save. So what will happen now? I'm going to use the same slope. Slope did not change, but the position of the slope. Okay. So with this, right? Okay. What is going to happen? So if you add both of them, right? If you add the both of them, the slope is still the same. So originally, due to bending, it looks like this, right? Originally. So when you add both of them, it's been pushed this way, right? So now, this is still our 0. Okay, so this is a very typical characteristic, okay, a very typical characteristic for our eccentric bending. So we're now at 0, right? At this line 0, right? This point 0 over here, right? This is our centroid. Okay, right? But our neutral axis is not at the centroid. I repeat again, the neutral axis is not a centroid. Now the neutral axis did something, right? You can see now, this is the position of our neutral axis. So what you see is that there is a shift, right? There's a shift. So that is a very typical characteristic of eccentric symmetrical loading. Okay, so I'll write down here. This is important to take note. So you see there's a shift, right? Last week when we did those, when we did the problems in eccentric loading, the centroid is equal to the what? Neutral axis. For eccentric loading, the centroid is not equal to the neutral axis. Okay. So now, so in I'll write this down. Okay. So in centric symmetrical loading, where we have stress X is equal to mz over izz multiplied by y, right? The location of the centroid and neutral axis. When I say neutral axis down here means stress X is equal to 0, are the same position, are the same. Okay, right. So this is for centric. Okay, the word to focus now is centric. Okay, so in eccentric, symmetrical load, where stress x now is equal to px over a plus by mz over izz multiplied by y. Okay, the location of the, okay, so I'll just copy this, just paste, right? The location of the centroid and the neutral axis are different. Okay, so this is where I'm going to highlight this. This is where you see the shift. Okay, you see the shift. Okay. Any questions so far? No? Okay. So what if now, right? If I draw the same figure, right? If I draw the same figure, I'm only going to change the direction of the, only will change the direction of the force applied, right? So this is rotation in our Z. What if now I change the direction of the what? Of the force. Okay. So the location of the force now, the location of the force now, I flip it over. Now we have what? P prime. Right? It's so typical me for doing this for you in your exam or in your term test. So what you see now, when that's the case, at point C, right, Px will now go into what? Compression. So now, how will this structure deform now is different also, right? Because the moment is applied differently. So at point C, this location is a point of interest because it will fail over there. Now, how this structure will deform now, it will deform like this. Okay, so it will deform like this. Oh, wrong color. So you deform like this. Right? So now this is your what? P prime. So what is going on down here is now your moment change in direction. Okay, so now the top will become tensile, the bottom will become what? Compression. So if you were ask me to sketch the stress profile now, okay, so I'm going to sketch a stress profile. Right, so this is my stress X. This is my Y. Right, so this is my Y. So what you see now, right? So now the top will be tensile, the bottom be compression. So the formulas that we apply will be stress X is equal to P X over A plus by MZ over IZZ multiplied by Y. So now your structure, this term over here will be under what? Compression. Right? So how your structure will behave now? So if there is no if it's eccentric loading, it will look like this. Sorry, eccentric loading, it will look like, so the top be tensile, the bottom will be what? Compression. Right? So now it gone into more compression, right? So again, you have your shift. So this moving towards the left is more compression, right? So again, there will be a shift in your neutral axis. Okay, so right. So over here, your zero over here, this is based on a centroid. Now the centroid location, we find the centroid based on what? Geometry. Yeah, it's based on geometry. And this is the actual position of your neutral axis. Okay, so the difference is obvious. Okay, so because of how structure loaded, the stress profile is also different now. Okay. Question, anyone? I don't hear anything yet. Okay, so if that's the case, we're gonna do an example. I think this is best done by learning from examples. Okay, once you get you see the example, then it's real straightforward. But again, if you were to ask me, did you learn anything new compared to last week? I tell you, you learned nothing new. I say again, you did not learn anything new. The analysis is still the same. That positive, the vector moment arrow, the head, right, is always what? Compression. The tail end is still tensor. Still the same. Okay. So the only thing that you learn is that there's a shift of the what? There's a shift for the neutral axis. So the neutral axis is now not located at the what? At the centroid. So you have to be very observant regarding this. Okay. Now let's look at one question. Okay, let's look at an example. So we're going to do this example. I'm going to copy the and I'll need another one. Now you can get all these images on Avenue to Learn. Okay, I've uploaded them on Avenue. Right. So let's look at example number 1. So knowing that the clamp has been tightened on wooden planks being glued until P is equal to 500. Determine in section A the stress at point A and the stress at point D, and then the location of the what? Of the neutral axis. Okay. So sometimes when you read the question, you must be wondering, why do you need to find the location of the neutral axis? For this case, right? The last part, then they ask you to find the location of the neutral axis because there's a shift. Am I right? So if you see if there's a shift, then you know that, hey, this is not centric loading. Okay. So one student asked me why this is not minus. It is minus, okay, but I just wrote down here compression, so we're going to put here minus px away. But I did highlight there that it's compression. Okay, thank you to clarify that. Right, coming back to here now. So we're going to find the stresses at A, point D, and the location of the neutral axis. So I want you to take note. What is important is choosing the position of the datum. Okay. So we're going to choose the position. So for this case, the position of the datum is best to be taken from the top. Okay. So this is the position of the datum to determine the position of centroid. Right? So why is that? Because we know that if we take from the top over here, this is the distance we're going to find, which is going to call E.